Hello, I'm N.Kripa, Assistant Professor, Department of Biomedical Engineering from Bharat Institute of Higher Education and Research, Chennai 73. The course we are going to see is Biosensors and Measurements. The topic we are going to cover is the stain gauge and its types. Now, before going to see about the stain gauge and its types, we have to know about what is a transducer. Transducer is an electronic device that converts a signal in the form of energy into another form of energy. It converts energy to a readable form. Example, a thermometer that converts the heat energy into height of mercury column. Some other examples of transducers are microphones, loudspeakers, thermometers, pressure gauges, LEDs, and even the common bulb are considered as transducers. Next, we can see about the classification of transducer. As you can see from the chart, there are different types of transducers. So based on this classification, the first one is classification based on the principle of transduction. The transducer is classified by the transduction medium. The transduction medium may be resistive, inductive, or capacitive, which depends upon the conversion process, that how the input transducer converts the input signal into resistive, inductive, and capacitive respectively. The next kind of transducer is primary and secondary kind of transducer. The transducer consists of mechanical as well as electrical devices. The mechanical devices of the transducer change the physical input quantities into a mechanical signal. This mechanical device is known as primary transducer. The secondary transducer converts the mechanical signal into an electrical signal. The magnitude of the input-output signal depends upon the input mechanical signal. The next kind of classification is passive and active kind of transducers. The transducer, which requires the power from an external power source, is known as passive transducer. They are also known as the external power transducer. The capacitive, resistive, and inductive transducers are examples of passive transducer. The transducer, which does not require the external power source, is known as the active transducer. Such type of transducer develops their own current or voltage. Hence, sometimes it is also called as self-generating transducer. The output signal is obtained from the physical input quantity. The transducer can also be classified by their output signals. The output signal of the transducer may be continuous or discrete. Now, the next kind of classification is analog and digital kind of transducer. The analog transducer changes the input quantity into a continuous function. The strain gauge, LVDT, thermocouple, thermistor are some examples of analog transducer. Digital transducer. The transducer which converts the input quantity into a digital signal is called digital transducer. The digital signals work either on high or low power. The last kind of classification is transducer versus inverse transducer. The device which converts the non-electrical quantity into an electrical quantity is known as transducer. The transducer which converts the electrical quantity into a physical quantity, is known as inverse transducer. A transducer has high electrical input and low non-electrical output. Next, we can see about the resistive transducers. Resistive transducers are those in which the resistance changes due to the change in some physical phenomenon like the environmental effects. They can also be used for measuring various physical quantities like the temperature, pressure, displacement, force, vibration, etc. The change in resistance is measured by the AC or DC measuring devices. The measurement of the physical quantity is quite difficult. So the resistive transducer converts these physical quantities into variable resistance, which is measured by meters. The process of variation in resistance is widely used in industrial applications. The resistive transducer can work both on primary as well as secondary transducer. The primary transducer changes the physical quantity into a mechanical signal, and secondary transducer directly transforms it into electrical signals. Now coming to the working principle of resistive transducer. The resistive transducer element works on the principle of the resistance of the element is directly proportional to the length of the conductor and inversely proportional to the conductor area of the conductor. So the resistance of the electrical conductor is given by R is equal to rho L by A, where R is resistance in ohm. P is the resistivity of the conductor. IL is the length of the conductor in centimeter. A is the area of cross section of the conductor. Now it is clear from the equation that the electrical resistance can be varied by varying the length, cross sectional area, and the resistivity, or the combination of all these three. Next, we can see about the strain gauge. If a metal conductor is stretched or compressed, its resistance changes on account of the fact that both the length and diameter of the conductor changes. Also, there is a change in the value of the resistivity of the conductor when it is strained, and the property is called piezoelectric effect. Therefore, resistance strain gauge is called piezoresistive gauge. The strain gauge are used for the measurement of strain and associated stress in experimental analysis. Secondly, many detectors and transducers like the load cell, torque meters, diaphragm type pressure gauges, temperature sensors, accelerometers, and flow meters at strain gauges or secondary transducers. Now coming to the theory of strain gauge. If the strip of this elastic material is subjected to tension, its longitudinal dimension will increase, while there will be a reduction in lateral dimension. So when a gauge is subject to a positive strain, its length increases while the area of the cross section decreases. Let us consider the strain gauge to be made up of circular wire. The wire has dimension of length L, area A, and diameter D. Please refer to the diagram which I have given here before it is being strained. So its resistance will be rho. Therefore, The force of the resistance of the strain gauge is R is equal to rho L by A. Let a tensile stress be applied on the wire or into the surface of the structure which is under study. Now, what will happen is it produces a positive strain coming on the length of increase and area to decrease. Thus, when the wire is strained, there is a change in dimension. Let del L be change in area, del D be the change in diameter, and del R be the change in resistance. Types of strain gauges. Strain gauges are broadly classified into two types. One is unbonded strain gauge. Another is bonded strain gauges. Under bonded strain gauges, there are three types: fine wire strain gauge, metal foil strain gauge, and semiconductor strain gauges. We will see all these one by one briefly. Unbonded strain gauges. The arrangement of an unbonded strain gauge consists of the following. These strain gauges are directly bonded, that is, pasted onto the surface of the structure which is under study. Hence, they are termed as unbounded strain gauges. The arrangement of this unbounded strain gauges are two frames P and Q carrying the rigidly fixed insulated pins as shown in the diagram. These two frames can move relative with respect to each other, and they are held by a spring labeled mechanism. A few wire resistant strain gauge is stretched around the insulated pins. The strain gauge is connected to a beadstone bridge. Now, coming to the operation of this unbounded strain gauge, when a force is applied onto the structure which is under study for the frames P and Q, the frame P moves relative to the frame Q, and due to this, the strain gauge will change the length and cross section. This is the strain gauge is strained. This strain changes the resistance of the strain gauge, and the change in resistance of the strain gauge is measured using a beadstone bridge. The change in resistance when calibrated becomes a measure of the applied force and change in dimension of the structure which is under study. Now, coming to the applications of this unbounded strain gauges. Unbounded strain gauge is places where it works in many industrial sectors, where these gauges can be detached and can be used again and again. The unbonded strain gauge used in pressure, force, and acceleration measurements. Now, coming to the advantages of unbounded strain gauge, the range of this gauge is between plus or minus 0.15% strain. The gauge has a very high accuracy when compared to other kind of gauges. Now, coming to the limitations of this unbounded strain gauge, it occupies more space when compared to other strain gauges. The next type of strain gauges are bonded. So, in this bonded, these gauges are directly bonded or pasted onto the surface of the structure which is under study. Hence, they are termed as bonded strain gauges. There are three types of bonded strain gauges. They are fine wire strain gauge, metal foil strain gauge, and semiconductor gauges. So the first one is fine wire strain gauge. You can refer to the diagram. The arrangement consists of the following parts. The fine wire diameter of resistance 0.025 mm which is bent again and again as shown in the diagram. This is done to increase the length of the wire, and it permits a uniform combination of the stress. The resistance wire placed between the two carrier base filters, that is papers, up backlight or Teflon, which are connected with each other. The carrier have been protected the gauge from damage. Leads are provided for electrically connecting the stained gauge to a measuring devices like Wheatstone bridge. Now coming to the operation, so when the help of the adhesive material, the stained gauge is pasted or bonded onto the structure which is under study. The structure is subjected to force or tensile stress. Now what happens? The structure will change the dimension. As the stained gauge is bonded, the structure, the stained gauge will also undergo change in both the length and cross-sectional area which is being stained. The stained gauges changes the dimensional change, then maintaining of the stained gauge, which can be measured using a Wheatstone bridge. The change in resistance of the stained gauge becomes the measure of the extent to which the structure is strained, and the measure of the applied force is being calibrated. The fine wire stained gauge materials are made up of many materials. Some of them are nichrome, which is made up of nickel 80% and chromium 20%. Constantine, where nickel is 45% and copper is 55%. Coming to the advantages of this fine wire stained gauge, the range of this gauge is either plus or minus 0.3% of strain. The gauge has a very high accuracy. The limitation of the fine wire stained gauge include these gauges cannot be detached and used again and again because the gauges are hold on to the structure which is under study. These gauges are so costly because of it. The next kind of stained gauge is metal foil stained gauge. The arrangement consists of the following. Please refer to the diagram. The metal foil is of 0.02 mm thick, is produced using a printed circuit technique. The metal foil is produced on the side of the plastic like bakelite or Teflon. Leads are connected or soldered onto the metal for electrically connecting the stained gauge to a measuring instrument like a Wheatstone bridge. Now coming to the operation of the metal foil stained gauge. So with the help of an adhesive material, the stained gauge is it's pasted onto the structure which is under study. Now the structure is subjected to a force which is like tensile or compressive force. Due to the fact force, the structure will change the dimension. As the stained gauge is bonded onto the structure, the strain gauge will be undergoing changes in both the length and cross-sectional area. The strain gauge changes depends upon the change of the resistance of the strain gauge which is being measured using a Wheatstone bridge. The changes the resistance of the strain gauge becomes a measure of the extent on which the structure is strained, and the measure of the applied force where it's been calibrated. Some of the fine gauges are used in varied medical instruments and also for industrial applications. Now coming to the advantages of metal foil stain gauge. The stain gauges can be manufactured in any shape. The backing, which is like Teflon, can be peeled off of the metal foil and can be easily directed to the structure which is under study. In such cases, a ceramic material is being used. These gauges have a better lifetime. They have good sensitivity and have stability even at high temperature. And the next is semiconductor stain gauges. The arrangement of a semiconductor stain gauge is as follows. Please check with the given diagram. The sensing element is rectangular filament which is made up of a wafer which is formed from silicon or germanium crystals. To these crystals, their boron is being added, which gives some kind of desired properties onto the process is called doping, and the crystals are called doped crystals. The scanning element of the metal to a place is being stained and baggage is being added. Leads are made up of gold and drawn from the sensing element of the electrically connecting the gauge and by measuring it to an instrument like a wheatstone bridge. Now coming to the operation of this semiconductor material, with the help of a adhesive material, it is being pasted or bonded onto the structure which is under study. Now the structure is subjected to a force like tensile or compressive force. Now due to the force, the structure will change the dimension. As the stain gauge is bonded onto the structure, then the stain gauge will also undergo change in both the length of the cross-sectional area that is being strained. So when the sensing element or crystal of this semiconductor stain gauge is strained, its resistivity changes continuously to a change in resistance of the stain gauge. The change in the resistance of the stain gauge is measured using a wheatstone bridge. The change in resistance of the stain gauge becomes a measure of the extent to which the measure is strained and measured for the applied fine force is being collaborated. Now coming to the advantages of the semiconductor stain gauges. These gauges have high gauge factor and hence they can be measured even very small strains. These can be measured by very small stress. They have a good frequency response. They have good lifetime. Now coming to the limitations of the semiconductor stain gauge. These gauges are brittle and hence they cannot be used again and again. The gauge factor is not constant. These gauges are the most costly and it's difficult to be bonded onto the structure which is under study. These gauges are sensitivity to change in temperature. Now coming to the last topic, that is rosettes. When a stain gauge is being connected with each other, many stain gauges connected to each other like a petals of a rose, it's called rosettes. A stain gauge rosette is a term for an arrangement of two or more stain gauges that are positioned closely to measure strains along with different directions of the component which is under evaluation. Single stain gauges can only measure strain effectively in one direction. So the use of multiple stain gauges enable more measurement to be taken, providing more precise evaluation of the stain on the surface which is being measured. So here are some examples. So in addition to the single element stain gauge, combination of stain gauges called rosettes has been available in the market in many combinations for specific stain analysis or transducer applications. As the element may be subjected to stress in any direction, and hence it has not been possible to locate the direction of the physical stress. Therefore, it is necessary to locate the strain gauge measurement system which measures the values of principal strain and stress during the Wheatstone bridge is being directed. So the examples include a 3 strain gauge which is being placed in a 60 planar, two strain gauge combined together and forms a 90-degree stacked, and three strain gauges are being combined together and form three element 60-degree planar. So the combination of strain gauges is called rosettes, like a petals of rose is being arranged, and the measures of the value of the principal strain and stresses is also being very helpful. So these are all the types and examples of strain gauges. Thank you.